In the next 15 minutes, you'll discover just how a helicopter flies. We'll take an interactive exploration into the basics of helicopter flight. We'll cover the 4 forces of flight, and we'll show how the airfoil works, and finally go over the flight controls and what they do. For the purpose of this example, we'll place the helicopter in straight and level flight. Every aircraft has 4 different forces acting on it at all times: weight, lift, thrust, and drag. These forces act in pairs and are always in direct opposition to each other. It is these forces that we must manipulate in order for an aircraft to fly. From this list: drag, gravity, weight, resistance, lift, thrust, and air pressure. See if you can select the answer that affects the helicopter in the direction shown. Exactly. Now select the force that acts directly opposite to weight. Right. Directly opposite the force of weight is lift. If the helicopter is to fly, its weight has to be lifted off the ground. If the helicopter is to move through the air, it must have some type of propulsion. What do you think this force is called? Exactly. The force that moves the helicopter through the air is thrust. And what would be the force working against thrust? What force causes resistance to something moving through the air? Yes, in an aircraft, anything that resists movement is called drag. So to sum up, the 4 forces acting on an aircraft in straight and level flight are weight, lift, thrust, and drag. Weight and lift are acting vertically, while thrust and drag work horizontally. If lift is greater than weight, the helicopter will move up. If weight is greater than lift, it will move down. If thrust is more than drag, the helicopter will move forward. If there is more drag than thrust, it will slow down or stop. Okay, let's move on. The way we generate lift is through an airfoil. Airplanes have wings. Helicopters have rotary wings called rotor blades. If the speed of the airfoil increases while moving through the air, the lift also increases. Lift can also be increased by changing the angle of the airfoil relative to the direction of movement. This is called the angle of attack. However, as the angle of attack increases, the amount of drag also increases, making it harder for the airfoil to move through the air. There are a number of principles actually involved in producing lift. We are greatly simplifying what actually happens and won't be going into aerodynamic theory here today. However, it is important to understand that the airfoil produces lift, and the amount of lift varies with speed and angle of attack. Let's move on. With traditional fixed-wing aircraft, the faster it moves through the air, the more lift it produces. But a helicopter can fly without any forward movement at all. It can hover. Rather than moving the whole aircraft through the air to generate lift, helicopters use rotary wings. It is this ability to separate the aircraft movement from the generation of lift that allows a helicopter the advantages of vertical takeoff and landing. Helicopters don't need runways, and forward movement isn't required for the helicopter to maintain maneuverability. As the rotor blades spin, they create an aerodynamic force, which is a combination of lift and thrust. We'll call this total rotor thrust. An important thing to remember is that the total rotor thrust is always perpendicular to the tip path plane of the blades. In this animation, you can see that total rotor thrust is not always 90 degrees relative to the helicopter, but 90 degrees relative to the path of the tips of the rotor blades. The ability to vary the magnitude and direction of the total rotor thrust is what allows us to control the helicopter. Before we go on to how a helicopter hovers and moves through the air, there is something else we must first cover. To accelerate the rotor RPM is increased by turning the throttle located on the collective stick. A helicopter is designed to fly with the speed of the blades, the rotor RPM constant with little variation. So we turn the throttle to increase the power, which in turn increases the RPM of the blades. However, when we bring in power, there is a law, one of Newton's 3 laws of motion that will affect a helicopter. Do you know what that law is? The law of action and reaction, the law of inertia, or the law of acceleration.